second video for Structs. Just want to crank through all of these. You notice my shirt has not changed, so I'm just doing these in a row. We've been looking at just how to declare a struct. Now let's actually access individual elements in a struct. Well, as I said last video, just very briefly, if I have a struct name David, for example, of type student, right here, student David. If I want to get the email for David, I will go david.email, or if I want to get David's name, david.name. It is the name of David. It could be, it doesn't have to be the name David, it could be student one, right? It still need a proper name. Or david.id is the ID for that particular student struct. This is just a whole bunch of data bundled together, and to get the individual field in that data, I put a dot. When we deal with pointers later on, I just want to preamble things. When we deal with pointers later on, if I'm dealing with a pointer to a struct, I would use an arrow, not the dot. But for the time being, every time we want to access an individual element or an individual field within a struct, I put a dot. So here's student David, here's a class of size 20, all of which are students. If I want to get David's name, well, I could say david.name is equal to David Sprague. I will point out these strings are going to be not quite right, but that's fine. Oh, they'll be right in here because I have a constant character pointer. So I'm pointing to some string named David Sprague. I have an ID, and I can set the ID to just say this number here. I could get the fourth student in the class and set their email address. So here is the fourth student in the class, and I can set the email to be dylansmith@carleton.ca, and the fourth student in the class, and I can set the name to being Dylan Smith. I can go into individual parts of an array and just put in values for the name or the email address. This is how I access individual fields for a particular student. So this gets me the individual student, the student struct. This gets me the field within the student struct. So we're going to look at one more time. So outside of one of the problems that you might have is this, again, does not make a student. It is not a global variable. This is the blueprint on how I make a structure. So a lot of times I will just put my structure definition at the top of my file, essentially making it global so anyone can see what a structure looks like. Anything in the file knows what that kind of structure is. It doesn't have to be in a function. If I put it in a function, that only exists within the function and then gets destroyed. If I put it out here, it's essentially a global definition for what a student structure is. So I normally put my structures at the very top of my file so that everything in the file knows what that structure is. Okay, so I don't put it in, I put it outside of my functions as like a global. So now that I have this outside of my function in main, I can make a student named David. I can set all the parameters for David, one after the other, and then I can print off information about that student. Okay. Let's do this one more time. So the CD account, I don't even know what that's supposed to be for, but we're going to use it as an example. It's talking about balances interest rates. So here I'm making a CD. I'm making an account. When I do, I will make a structure with a double, and an int. Great. It will be a bundle of things like this. And what's in each of those fields? I don't know. If I don't declare things, what those variables are, what those fields are, it could be anything in there. You can assume certainly, but you shouldn't assume, right? So let's assume that we are going to assume we don't know what's in there, and therefore we should be very, very careful. If I make a CD account, I should either set all the variables or be well aware that those aren't set yet. From there, if I set account.balance and set it to 1,000, now the balance field, this bucket right here, the value 1,000 gets added. If I do it again for interest rate, I'll stomp in 4.7 in the interest rate field. If I do the term, stomp in the number 11 into the term. It's the same structure with 3 different fields, and I can go with individual fields. Now, if I don't want to initialize my structure this way, one after the other, I can do it like this. When I make a new student S, I can put in all the various fields that I'm going to use, the email address, the name, the ID, and the GPA. 1, 2, 3, 4 different fields in a curly parentheses, and that will initialize what S is to be s@c.com, Joan, and whatever these numbers are. I can also do it after the definition, so s.name is equal to Joan, but if I want to do it all in one go, I can technically do this. I don't do this very often myself. I'm error prone, so unless I really know what's going into that structure, I won't do that all in one line myself. But you're perfectly feel free to do that yourself. All right. Also, I want to note that this is not necessarily, this code, the syntax for this code is not exactly right, and it sort of irked me a little bit. We have an array of characters here, which is like saying char star. This won't actually work because Joan will not be stuffed into email because just how strings work. For the time being, we're going to pretend magically that the word Joan is, the name Joan is going to go into the name here, but it's not exactly going to work that way. So when we get to strings, I think next lecture, we will, or soon, very, very soon, we'll see why this isn't going to actually work. But for the time being, just imagine I can just put in the string Joan into the name and I'm good to go. It's not true in this case yet, but we will see that. We will see this shortly. I wanted to simplify things. Okay. I could also just initialize some of the variables if I just put in the first field or this first and the second field. I'm fine. I will only initialize the first and the second field. It's done in the order in my structure, so it'll go email, then name, then what's the other field? Then ID and then GPA. So if I add 3 fields in a row, it needs to be email, name, and ID. And I cannot skip over a field. This is illegal. I didn't put in my ID. The whole thing is illegal. I cannot initialize my student that way. So this only works if I include everything up to a certain point. So that's what makes that illegal. So here would be me using a structure with an ID, an age, a grade 1, grade 2, and an average. Let's say I wanted to do a function that prints out the average. Well, I would pass in a student S in this thing, and I could get the average and print it off. This will make a brand new variable named S from whatever called this function. The value for S, though, will be set up initially based off of what calls it. And now I have S.average. I can just access the individual field and spit out what the average is. Or I can print off the ID, the age, the grade, and the average. Right? Instead of having to pass in 5 different variables, I just pass in a student. I can also return the student. This is where I find it a little weird. So here's my prototype. Get student data. It's going to return a student. Maybe, or make new student data, or whatever I want to call it. So this is going to make a brand new student with set blank fields in it. So I could call stu1 is equal to get student data, and that will make a brand new student and the stu1 will be that brand new student. So I want you to notice that it will define it. When I do this, I need to define a new structure within here, and then I return that structure at the end. That's what I'm doing here. So why is that not a problem? So here is get student data. If you wanted to write it yourself, you can try it on your own, but here is get student data. I'm going to make a brand new student. I'm going to get from the user the 4 of the 5 different parameters. I'm going to calculate the average. Maybe I have a function for calculating the average, right? For stu1, and maybe calculating an average is another function that takes in the full student data type and calculates the average. And then I return temp_stu. Now, this entire time I've been telling you that when I make a local variable, at the end, when I'm at the end of my function, the local variable is destroyed. So temp_stu should be destroyed. So why am I allowed to do this? Why is that not a problem? So think about it for a second. Why is that not a problem in this particular case? I make a new variable here brand new variable. I just return the brand new variable. Why is this not going to cause any kind of issues? I don't know if I have it yet. Well, the actual reason I don't have any issues is because of this. I can make a brand new student called, student stu1 is equal to get student data. This will make a brand new student. It will pass the values for that student, all the values, all the different fields. It's a giant chunk of data. So all the values will be sent across over here, and stu1 will have all of its variables set to be matching this thing over here. I'm still passing just values around, but it's not, instead of the numeric number like returning an integer, just returning some number, it's a whole bunch of numbers one after the other. But it's still allowed. I'm still only sending values. I'm not passing around the variables themselves. I'm just passing the values. And stu1 would then set its values to match whatever the values this thing returns. So try it on your own if you don't believe me. But the interesting thing here is this allows me to pass in or pass out more information than a single variable. A structure allows me to pass out, this thing will pass out 5 different variables all in one go. It'll pass out the ID, the age, grade 1, grade 2, and the average. So this is one of our workarounds. If I need to return, let's say I have to return an X and a Y coordinate. I make a structure called point, and then I return the point, which has an X and a Y coordinate, and I can pass back out 2 variables instead of just 1 using a structure. In case you've been hitting this scenario over and over again, like my function only returns one thing, that's useless. Well, structures allow you to work around that. You return one structure, and that structure can have multiple pieces of information. It could be, let's say, 5 pieces of information. It could be an array for all you know. We can have arrays of structures. So here is pay information. It has an hours and a pay rate. Fine. We've already looked at one of these examples. I'm going to make 3 workers. Notice it's all caps. This is a constant integer. It's not going to change at all. That's why it's all caps. So this is going to make 3 workers. So I can have an array of these structures, and I can get individual elements of that structure. I could then go through with a while loop, pulling out all the various workers. In fact, that's what I'm going to do next. So enter the hours worked by person blah, employees and the average wages. Okay, so for each one of these workers, there's 3 workers. I get the hours worked by the employee. So this is a printf statement asking for the information. Then you type in a number, and it's going to be going to whatever index I am at, 0, 1, 2, 3. So there's a grand total of 3 people. Number of workers is 3, 0, 1, 2, right? It's going to loop around 3 times because this is the value 3. Let's actually just put that in there. It's going to loop around 3 times. So worker at index 0, I get the number of hours. Then I get the pay rate for worker 0. And then I print out a new line, go around again, get the information for index 1, get the information for index 2. It allows, with a for loop and an array of structures, I can get all the information for all the various structures. Well, and we can go from there, and I could say, okay, let's print off the gross pay for each employee, and so I can access and print off information about the structures. So here I am going to go around 3 times again, and I'm going to get the gross pay, which is the number of hours worked multiplied by the pay rate for that individual person. So for person 0, worker 0, the pay rate multiplied the number of hours that worker worked. That will give me the gross pay, and then it says employee 0, colon, and whatever their gross salary is for that week. So we'll get things like this, right? I will enter in the hours worked by the employee and their pay rate, hours worked by the employee, pay rate for each one of those structures. And then this is what I would expect to see printed out in the second for loop. Here's their gross salary for that week. There's a gross salary for that week. There's a gross salary for that week. because I can have arrays of structures, I can also have structures of arrays, or structures with arrays. So we can have my grades. This is actually would be very, very useful if homework aid is what it was in previous terms. It's going to be very, very useful. I may have a structure of all your assignment grades. So what I might want is all the assignment grades, the number of assignments that you did. So let's say it's, and then we'll also have an array of, so we can have a structure which is like grade group or something like that. So it would be, let's say, assignments. We have 11 assignments, number of grades would be 11, but then we also have quiz grades, and we may have 20 quizzes and all the various quizzes put together. They are an array of integers, and the whole thing would be just all of the information about the assignments, or all the information about the quizzes. I can, instead of having to say I have an array of integers and now or an array of floats, I can just say I have all the information I need about the assignments in one go. I could put other fields in there, like say number of grades counted, and then here's my list of all my grades, right? And I can calculate your average for all of your assignments just with that bit of information. How many assignments are we dropping? How many assignments did you do? Therefore, what is and then all of your grades for all your assignments, and you can calculate what your average is for your assignments. This is really useful for just sort of simplifying things. I now have a general solution. You pass in one of these my grades structures with assignment grades, and then you pass in call the same function again with a different structure of your I said assignment grades, so your quiz grades, and maybe your exam grades, and the exam grades have exactly one item in it, and you count that one item, right? It's still, the algorithm doesn't change, the function doesn't need to change, but I can calculate all the different ways you're being evaluated in this course. So you can have arrays within your structs, and you can have structs arrays made out of structs, or you can have arrays made out of structs which have arrays inside of them if you want. Whatever works. These are just little pieces that you can string together in a whole bunch of wide variety of different ways. So a structure can contain another structure. We've already seen this, right? So here's personal information. Here is a student. So I have a student ID, the year in the school, the GPA, and then the personal data, where they're living, for example, and their name. The personal data is another struct, and I can just throw that in my struct, and it's fine. We've already done that before when we did the rectangles and lines, where I put a point structure inside of the line structure. It's okay. As long as the point structure is defined beforehand, you can do it. To access that, this is what the data structure will look like when I make one of these students, right? With their personal information. To get the individual element, let's say like the name here, I just use the dot one more time. So here's the personal information. Here's personal information data structure. So it would be, I have a student s.pdata, this is field right here, s.pdata, this field down here, which is, and then dot name gives me the name for that person S. I could even do one level below that even. It just means I can go field within, I can do a struct within a struct within a struct, and I just use the dot to just go down my hierarchy. So this is, I have student S, I have dot, so student S dot pdata, I'm right here, and then from pdata, if I go dot and city, I go down to here, and this is what I'm looking at. This within this within this. And I could go even further. What about if I have a birthday data structure? So let's add, I want you to try this out. Let's try and add a birthday, make a birthday struct, and then add it to our data structures here that you see here, these data structures here, so that this works. What would that look like? How would that work? So first of all, we need to figure out what our birthday data structure is. It's going to be a day, month, and year, let's say. And then I need to figure out where I add that to this date, to these structs. And then I need to figure out so that this actually works, essentially. So what would I do? Well, I make a struct called, not necessarily called birthday, but it might be date, or my date. And then I have a day, a month, and a year as 3 different integer variables. And from there, I put my date, or date, depending on how I want to do this, birthday here. And the fields here would be day, month, year over here. So here's my data structure, date. I made a brand new data structure. It has a month, a day, and a year. And by putting the birthday in here, it allows me to access the individual birthday for that. It's a struct within a struct within a struct. It's okay. You can go even deeper than that. You can have arrays within that struct as well. There's no necessary limitations on this. So what have we been looking at so far? We've looked at loops. We've looked at functions. We've looked at variables. We've looked at conditionals. And now we've looked at one of the final pieces of the puzzle just to really get things going. And that's structs. It allows me to make my own, it's bring your own data type. It allows me to combine other existing data types together so that sort of give it a name to this one concept. And most languages actually have this. They may call them different names, but they sort of all serve the same purpose. And when you do object-oriented programming, it does this with a little bit extra. They have functions themselves. So it allows you to bundle related data, and you can have arrays of structs and structs of arrays, and by combining all these things together, you can hold anything you want. You can do really interesting things now, which is why we're going to be doing some of those interesting things when it comes to the Chinese horoscope, Chinese zodiac, sorry, and for calculating your final grades. When we come back next time, we're going to be looking at strings, arrays, and then after that, pointers. This is where things might get a little hairy for some of you. It shouldn't be that daunting, but one of the big things is you need to practice this to make it your own. And that's so that when if things get a little confusing for you next series of lectures, just make sure that you practice a bunch of examples on your own. All right. Thank you, everyone, and have a great day.